So we've had a lot of great conversations around renewables integration and the future for energizing the mining sector. And now we're going to move on to a very important topic, which is electrifying mines. And our first presenter is really leading the way on this with a world-class project. So it's my pleasure to introduce Peter Xavier. Peter is the Vice President, Sudbury Integrated Nickel Operations for Glencore.
Well, my pleasure. Thank you for the introduction and the invitation. My pleasure to be here, and I certainly appreciate everyone sticking around at the coveted anchor spot. So I guess we won't keep it too long. We have an exciting panel right after this presentation. But I guess my case study, I'll give you a little bit of an introduction to Glencore, followed by a very exciting project that we're working on, in which we've decided to be 100% battery electric equipment in terms of an underground mining application. So typical for a public company, we are public. This is not an investment presentation, of course. I encourage you to understand the risks of so doing so, if that's your prerogative, but this presentation is really about a case study. I guess quickly, I mean, from a Glencore perspective, pretty broad across the globe, trade in or market or produce 90 commodities across 50 countries. You could probably segment us into three sort of areas: base metals, which myself as part of the nickel group reside. We also have a copper, zinc, alloys group, etc. An energy group, which is mostly coal, natural gas, and oil, and then an agricultural division. So that's sort of how we're split up, again, across the globe. Since we're presenting here in Canada, just give you a bit of a snapshot of our presence in Canada. So it's really coast to coast, but most of our mining operations are base metal operations, if you will, are more concentrated around Quebec and Ontario. And so from a Sudbury perspective, about 1,300 direct employees, about 500 contractors, so about 1,800 people directly employed, and with an economic sort of support of about 8,000, 8,500 people in the province. So pretty significant to the economy of Sudbury, and have been there operating since the late 1920s. If you look at sort of the nickel business sort of more specifically, we have two ferronickel operations sort of more towards Western Australia and New Caledonia, which is an island off the east coast of Australia. Just put that aside for now. I'll focus more on the INO business, which is our sulfide nickel business. You see there sort of the hub, if you will. We like to think of it as Sudbury because that's where our smelter resides. We take the feeds from Sudbury, and I'll get into a bit more specific explanation around Sudbury in a minute. But we have a major nickel producer in our Raglan mine in northern Quebec. It comes into Sudbury. We bring in feeds from all across the world into Sudbury and then on to our refinery in Norway. So you can see a bit of a logistical challenge, and base metals is a bit unique that way, and that we're, from a logistical perspective, having to move, tremendous amounts of material between mines, mills, smelters, and refineries. And just as of note, I know a lot of the conference has been sort of on renewables. Sudbury is a bit different context, but our mine in northern Quebec, Raglan mine, is off-grid and historically been reliant on diesel for electricity production, but they have since in the last few years brought in 2 wind turbines and looking at storage applications. So, for them, obviously that makes a lot of sense. Not the focus of today's presentation, but I thought I'd mention it nonetheless. So moving on to Sudbury operations, these are my responsibility along with the Port of Quebec operations, where a lot of our material handling passes on its way to the smelter and its way to the refinery. We basically have 2 underground mines currently. One is Fraser mine. It's been around for a while. We have our Nickel Rim South mine, which is our more modern mine. It was in operation around 2010. Some interesting sort of elements from an environmental perspective. It has a LEED gold certified building, its office complex, which is, I think, unique for the time. VOD, ventilation on demand system, fully dynamic. That brought us tremendous savings in terms of energy usage. So a couple of sort of novel approaches even, and especially for the time that it was put into operation. It was constructed basically from 2003 and became an operation in 2010. I guess the advantage to Sudbury of note is we're just not just nickel producers. We're nickel, copper, cobalt, platinum, palladium, gold, silver. So, we do the spectrum that helps us obviously diversify in the marketplace, but I think also it's important to note a lot of the products we produce are very much needed for a lot of the things you've heard about over the last 2 days. And so our two mines feed our local concentrator. Our concentrator also takes feeds from other junior companies, and that business comes and goes depending on the market. Onto our nickel smelter, of course that matches up with our feed from Raglan, Sudbury. Internationally we compete for concentrates right across the globe. We do well when it's polymetallic in terms of competing for those. And we have an important secondary business as well. So batteries, turnings, most waste products with metal in it from other industries, we take into our smelter there in Sudbury. So from a product life cycle perspective, we produce a lot of the products that go into batteries, and we're able to use them in our BEV applications, which I'm about to talk to, and finish it off with recycling it back through our smelter. So it's a nice complete story and something we're proud of as well. From a safety perspective, like most companies, I think we've seen our total reportable injury frequency come down. The numbers there, probably can't read them from the back, but I'll just focus on the trend. These are per million workforce hours and include our contractors. A bit of a blip this year as our contractor load comes up. Our contractors represent about 60 to 70% of our recordable injuries, but we take full accountability for them. But as we build new projects, we've seen a large influx. But the point of the slide is really to say, the presentation is not about all the things you need to do to manage safety, but it's to say that, innovation has a place to change the risk profile of our operations. And so there's examples there for geotechnical modeling or autonomous, you see an autonomous scoop operator where he's monitoring from surface, different examples. Those, of course, remove people from the hazards. And the scoop tram you see is a battery electric scoop, and so, what that allows us to do, and I'll speak to more of that in a minute, is it eliminates diesel contaminants underground. So from a health and hygiene perspective, it completely changes the context of your operation. And so it's just to sort of note that innovation has not just an environmental component or a productivity component, it has a real safety imperative as well. From a smelter perspective, not only GHGs in general, but SO2 has been an important emission for us to manage and decrease over time. Represented in the blue bars is our SO2 emissions over time. The red line is nickel production. So the smelter has challenges to increase nickel production while reducing SO2 emissions. We're able to capture a lot of that and produce sulfuric acid and sell that as a product. And so you have to manage those things, manage our costs, because we have to compete on a global marketplace to attract feeds to our smelter, and we also sell on a global market in terms of we're more of a price taker than a price giver. So it's something we have to be cognizant all the time, and we have to always figure out a way to innovate internally while maintaining sort of our cost competitive position. And a lot of novel innovations have happened in the smelter to do that, which I won't get into, but it's an important piece. And also on environment, we've been ISO 14001 certified for well over a decade as part of our commitment. That extends to our Port of Quebec operations as well, even though we manage it third party. We're also Green Marine certified in our shipping process between Raglan and our refinery. So strong commitment and evidence on our environmental side of things. Quickly, we have very key stakeholders in the community, one of which being our Indigenous partners. So 3 First Nations and Métis are important in that. We have very important, open, collaborative relationships. So that's an important part of our community engagement, as well as giving back to the community to which we operate. So we like to invest in things that give back to the community and capacity building areas, and you see some of the key giving areas listed there. So that's just a bit of context of our operations. And it brings me to sort of the technology and our strategy. Right now, we have a pretty robust business that we built through a transition around 2008 and 9. But our challenge in Sudbury was that our life of mines was somewhat limited. Our current mines were coming to end of life around 2022 in the case of Nickel Rim, 2023, 4 in the case of Fraser, and we needed to reinvest. And so at the start of 2017, we embarked on a sort of a 5-year strategy with some key pillars. You see license to operate, people, our ability to adapt, excellence in our operations, and building our future as key pillars of that strategy. And so the building our future part was trying to get new investment. And that's really the context of this presentation. One of those key investments for us to sustain our operations into the future was the approval and support on our Onaping Depth project. And so, if I take the ability to adapt pillar and I sort of expanded it to give you a bit of a sense of our broader innovation strategy, you'll see it broken up into various pillars there. I apologize, I see the graphics aren't showing up very well. But you see there, I'm about to talk about battery electric equipment in a minute, but But it's not really our prerogative to be battery electric solely. We're sort of agnostic to the solution. We were looking to be dieselless. Now mines are already electrified in many ways. Most drilling activities, trams, things like that have been electrified for some time. But we want a complete dieselless solution. Right now that solution is battery electric from the context of OD. But there's challenges with battery electric equipment. There's still a batch process. They're still not fully continuous. But it's just an example that that's our solution now. But it's not the principle by which all decisions are made. Digitization efforts, you hear a lot about that, of course. Our goal there is the same: real-time digital smart applications, real-time information for quick decision making, as well as being able to analyze trends on a longer time scale. Autonomous operations with the understanding that we have to get continuous first. So a lot of the mining operations is very cycle driven, different equipment, different skill sets for different parts of the cycle. So we have to try to get that sort of in a more continuous mode, and then think about how to automate that more simplified flow sheet in the underground environment. So we're doing a lot of work and collaborating with other companies to try to get to sort of what the holy grail is a continuous cutting operation. Mine design for depth. Our challenge in Sudbury is that we're having to go deeper after mining there for almost 100 years, and so there's challenges to that. So things are farther, they're hotter, logistics are a challenge, and so most things are moving in the wrong direction. And so design for depth means you have to have real solutions that match that challenge. And in some cases, even in using BEVs or continuous miners, you have to rethink even the way you design your mine. So in some cases, shoehorning an existing technology into the existing mine method is not the smart thing to do. So you have to step back and reimagine your mine design in general and make sure that's optimized first. So there's sort of a back and forth there. Agile ecosystem is just to say that we're working more and more with other companies, small, medium enterprises, OEMs, academia, you name it, to try to work together to solve some of these problems. In the past, you would see more R&D efforts led by large organizations. That's shifted somewhat, and so we're very much part of that ecosystem. And then sort of tailing off a little bit is something that's still in its early works, but concentrating along the path, of course. If I say that depth is a challenge because you're working against gravity that much farther, of course it makes a lot of sense to hoist less material. Even good grade nickel ore at 2% is still 98% waste, so you put in a lot of effort to bring that to surface, put it through a mill, etc. So obviously if you can change that paradigm, you can get benefits along the way. So I guess now sort of to the real sort of part of the presentation, which is the specific case study that I'm here to talk about. You see a picture there of Craig Mine. It was in operation until about 2009. It closed. We're currently give you a sense of the entrepreneurial spirit behind what we do in Sudbury. We're currently leasing it out to another organization that's using that infrastructure to access one of their nearby ore bodies. So it's part of a system that has a few interconnected mines in this part of the Sudbury Basin. We're now in the process of taking that back and looking to use it for our Onaping Depth project. And it's a nice picture because this is a mine that was built in the 80s, and from an environmental footprint perspective, I always think it's a good representation that mining isn't what I think most people on the street believe it to be, especially in a hard rock underground situation. And so it was a project that was discovered in the 90s, and it went through a lot of, different feasibility studies, different kicks at the can, tough economics, high capital, very long lead time to development, makes for tough NPV IR calculations, as you can imagine. And so it got worked multiple times, but it remained key to our ability to sustain our operations into the future. And at the time when it was found, deep underground hard rock mining, there was still a lot of uncertainty. So for us, it was imperative that we could ensure that we could safely operate at those depths. Certainly in the meantime, other companies have gone to those depths, and so we've learned from that. And then it was our chance to sort of refresh this study. And late 2016, what we did is made the decision to make it battery electric, 100% battery electric equipment application here. And that really was the last piece that allowed the economics to work. So why is that? Well, I mentioned earlier that we're going deeper and deeper and deeper. And so Sudbury, I think Sudbury's context is probably the best examples of an application of BEVs because it hits on multiple elements, which I'll go through. But it was key for us. Just to give a bit of a sense of sort of what the operation entails, in the grayed out sort of picture, you'll see the historic Craig and Onaping mines sort of grayed out. The top of the page of the diagram starts at 1,200 meters below surface. So you can see we're laterally developing out from that infrastructure and sinking a shaft to about 2,600 meters. And then moving from there to access the ore body. So you can imagine just some of the logistical challenge that brings. From a temperature perspective, you're dealing with 40 to 50 degrees, closer to 50-degree rock temperature. So obviously that's a challenge. And so brings us to battery electric vehicles. And some of the things I think what I'm going to try to do is give you some of the rationale behind why we chose that path, what kind of things you should think about if you're thinking about doing the same thing. So hopefully that's what you get from this part of the presentation. Off the top, hygiene is number one. Of course, things like reducing GHGs and those things are important, but hygiene improvements, that's direct correlated to human health. And of course, going to battery electric equipment removes diesel particulates, removes a lot of the gases. So obviously a big plus there. And in the sub-re context I mentioned earlier, why is it a perfect situation? Well, we're going to depth. First time ever we have to cool the air underground to make it hospitable for people. Being in a northern climate, we have to heat the air in the wintertime. So unfortunately in the wintertime, that means we've got to heat it and cool it again. And most infrastructure at a mine, especially with the Ontario regulations, is based on an air quantity per brake horsepower requirement. So it doesn't matter how clean your engines are, you need to deliver a certain amount of CFM or meter cube per second of air for the installed diesel working fleet. And so you can imagine, taking an existing mine and going deeper, having to take that quantity of air and push it even farther. So obviously from an intensity perspective, it's going in the wrong direction. And so by going to battery electric, we basically, put that sort of on its head and say, well, now we can be more on air quality than air quantity. The cooling plant, the heating plant, the amount of air that you have to heat in the winter, the infrastructure to deliver that air, both in terms of fans and just openings to deliver that air, all changes. And it's all those things together that really made this an obvious decision for us to move in that direction. And so just a couple things to sort of compare diesel versus the battery electric option. You see the size of the shaft was smaller, the vent raisers are smaller, the cooling plant is smaller. Also just on the left, you'll see a bunch of things that we were able to eliminate. So with less volume of air, we had to deliver a lot less air underground. Less openings, those openings could be smaller. Of course, that removes scope, removes capex, removes risk, because people would naturally have to do that work. And so when you put all those benefits together, you can get a sense of why it's such a compelling case. And you can see why we chose to go in this direction. Now, of course, from a GHG perspective, there is savings there. But most GHGs at a mine are the natural gas for us to heat the air in the wintertime. We're in 1 million plus liters a year, probably looking at a diesel option for on-pumping depth. Obviously, we're removing that, which is helping the GHG element as well. But for Ontario, especially Northern Ontario, we are blessed to be on the grid. Right now, currently our operations receive energy that is 99% carbon free, mostly nuclear and hydro. It's in surplus. And so, for us, we were sort of in a position to be taking advantage of that and in good stead in that front. And so our focus in terms of what we could do from a GHG perspective was obviously go in the BV direction. But if we were to simply try to justify the decision just on that element, you could see why it wouldn't fly. And that's why sometimes it's hard to match technology or innovation to very singular purposes. And it's really the broad spectrum of benefits that it brings, which is what makes this such a good case. And for us, there was a bit of a risk because when we first made the decision to do that, the marketplace wasn't currently providing all our needs. So we needed solutions for even the most obscure piece of equipment, your forklifts, your personal carriers, right to your big haulers. And not one OEM currently produces that whole suite of equipment. So that was a challenge. And so we had to take a bit of a risk as an organization. But we were doing a lot of work behind the scenes with the OEMs, telling them to sort of open up, show us what we're doing. And what we found is a lot of companies were actually pretty far along in terms of what they were doing in this space. And so that built us confidence. And what we've done is over time, over the last couple of years, is anytime we go to buy a piece of diesel equipment, we see on the marketplace if there's an electric equivalent, and we'll consider buying it, and then we're learning. We're teaming up with other companies to learn from other companies' experiences. So Kirkland Lake has done a lot of work. I see my co-panelist in the Minute Valley is doing some work, so as is Goldcorp, and so we're all working together and learning together. And we've tried a jumbo from Atlas Copco. We have Caterpillar in the room. We tried a few other scoop trams, the smaller units, mind you. McLean, we had a battery electric bolter, a boom truck, personal carriers from different suppliers. So we're learning, and then so we're starting to get confidence that the suite of equipment we need will be available. But I'll remind you too that mining is sort of a niche, especially underground mining is a niche market. Even finding something you really want that suits your needs on the diesel side of things sometimes is actually a challenge. But that's another story or a side topic. And so the availability on the big haulers, the 14-ton scoop trams, the 40-ton trucks, still a bit of an issue. But we only need battery electric to be available to meet our needs coming off our shaft development, which is around 2022. So we're confident based on what we see today that it'll be ready for that time. But there's stuff starting to hit the market now. So there's a 40-ton truck that's been in operation for a bit now. There's a second one coming on the market. Same thing with 14-ton scoop tram. So, but basically we're confident that's moving in the right direction. But these things are evolving as we speak. And so for us, obviously using the air quality versus quantity regulation is key. There's still some uncertainty around the performance aspects of some of these battery electric equipment. So my suggestion or advice to you is to stay in contact with OEMs and look to get their specs and verify in-field performance so that you can plan and design your mine more appropriately. And there's still some uncertainty on cost, of course, as the market is not to a state where there's a suite of competitive sort of options out there for you. So you still have to face a bit of a premium in the early days, but that'll, I think, change over time. And then don't forget about mine design. So you have to rethink your mine design. For us, going to trucks and needing 40 tons trucks underground meant that in order to be confident in the equipment could deal with the duty cycle we were going to place on it, we designed the mine to operate in a downhill loaded fashion. So we're taking advantage of the regeneration capability. Still a tough application to get a truck of that size going uphill loaded for any length of time. I mean, there's a limit there that you're going to probably go towards more trolley type systems. Of course, if you just keep making batteries and equipment bigger, you end up moving more equipment than you do the actual load, which is probably not an intelligent thing to do. So there's a balance there, but for us to mitigate against that challenge or that uncertainty was to design, like I said, make it haul downhill loaded, and that way we're able to get the proper cycles and try to fit that into our mine planning. And so a few things sort of off the top of my head, it's a bit of a list. I won't have time to explore each in detail, but I think just to give you a sense of things that we've come across and I'll share with you that's worth considering. So take advantage of regeneration, like I just mentioned. You got to make decisions around onboard or off-board chargers. There's different decisions to be made there, pluses and minuses. Battery swapping versus keep the batteries in the vehicle. In the early days, we were very anti-battery swapping because that meant, bringing it to an area that had a crane. You got rigging risks for health and safety perspective. It's time. But now, there's some pretty slick options that one OEM has it down to an 8 minutes battery swap cycle. So, things are improving all the time. And so where that decision might have seemed obvious for us at the beginning, it's changing. But there's still decisions to be made in that regard. Charge rates, of course, different batteries have different capabilities and the power they can take in. Of course, the higher charge rates you go, you're shortening your time, which is great, but then they usually need bigger installed infrastructure. You need to consider cooling. You're getting into much more intense processes. So there's a give and take there. Battery chemistries, of course, there's various ones to look at. You got to consider safety. Obviously, being in an underground environment, fire is always a concern. So I think you want to be conscious of that. Charging strategy. So, do you want to charge between shifts or at break times, or do you want to do what people call more opportunity charges? So if you're a boom truck operator, a flatbed operator, moving material, do you charge when you're loading and unloading that flatbed? If you're a truck, do you charge when you're loading, unloading? So that needs technology solutions to be able to do that and sort of get your couple minutes charge, at various opportunistic times. Or does it make more sense to just run it for a 3-4 hour cycle if it can handle that duty, park it, take a break, do a 15-minute sort of charge. So you got to consider these things in your overall design. And another thing to think about is parking charging locations. It's typically an afterthought in most mine designs. Most equipment stays in the area that it's working, and then there's a bunch of equipment that you basically have to find a place to park at the end of the shift. Maybe you can get away with that with diesel, but when things have to plug in and charge, you have to think about these things a little more closely. Charging management systems, so if you're doing between shift charging, you got everything plugged in, what sort of program system are you going to use to manage that? It's going to be on priority basis, like how is it going to make decisions? Do you got the juice to do all that at the same time? Things you'll have to consider and work through. Rent or buy batteries, so different OEMs will have different programs, incentives in terms of helping you make that decision. What do you do with battery disposal? There's more applications now to try to use second use life for sort of peak energy shaving. Of course, right at the end of life, like I mentioned earlier, if you have a battery that needs disposal that has metal in it, well, we're well poised, a little plug on our smelter to be able to take that off your hands. So, you got to consider these things, obviously. And finally, power quality. So the power you get to your site and you're able to deliver underground is a factor that you got to consider. So, not an exhaustive list, but just to give you a sense that these are things that you have to think about if you really want to optimize your BEV application if you choose to go in that direction. Other suggestions is, there's a Global Mining Standards Group. I know some of you are part of that. We were heavily involved because it's important when you have new technologies like this to get consistent standards. I mean, just to give you sort of an anecdote in terms of something everybody will be familiar with, you understand the challenge of having different chargers for your Android and your Apple products. Well, you don't want that situation when you're buying 100 pieces of equipment. So, things have to be all on the same page, and it was an important, necessary piece to get that right. And so there's some standards published, which is great. OEMs are committed to following them, which is great. Make your life a lot easier on the implementation phase. And CMIC, a plug for CMIC, we're in a consortium with various mining companies concentrating. They have different subgroups, but one of them is battery electric. So if you're interested in sharing with others and being part of a group of people that are moving in this direction, focused on this. There's a group on cutting, there's a group on other short level control. There's other groups, but there is one on battery electric equipment. So reach out to them if you're interested. And so, really in closing, hopefully I've given you a little bit of a taste on, our operations, why it made some sense for us to consider BEVs and what we've done in terms of trying to make sure all the pieces of the puzzle were in place for us to do that. Because there's no turning back for us. This mine is designed to be set up for battery electric equipment. When we come off that shaft, we're committed. Now we do have some backup options in case there's some slippage in timelines to go trolley or tethered, but there will be no capability to put diesel underground. So, and the whole vent system has been designed with that in mind. So, we're committed, and so we're very pushy when it comes to our interactions with the marketplace to be ready and to test their products, improve their products, and meet their deliverables. But, in closing, we have massive health and wellness benefits. That's fantastic. That'd probably be reason enough just to do it. Significant reduction in ventilation requirements, I think you'll see, especially in an underground environment, and that's just compounded if you got to go to depths that require heating or cooling. Lots of effort across the marketplace. Still early, so there's things left to be done, but I spoke about a few of those things, and then a couple of beliefs there to round it off. So. I think it's a wonderful example. It's an important piece of our innovation strategy, and thank you very much.